Okay, so this is an update on what's been happening recently with the Bitterbrush project, and I'll talk about the shrub age and nodulation survey, small, preliminary survey that's happened at each study site, the seed viability studies, the field plantings that happened this fall, and then seed germination for the greenhouse study that's being set up, and then the next steps that are happening. So the three study sites for this study are our lower elevation site at about 3,500 feet, down here at the lower woodchuck area, our mid elevation site at 4,000 feet up behind the orchard house, and our higher elevation site at 4,500 feet up Tongue Creek. Initially I wanted to figure out a way to age bitterbrush on the ranch without destroying the plants and having to dig them up and cut them and count age rings. So I did destructively sample 9 plants based on what to the naked eye, I picked an older looking one and kind of a middle sized one and then a younger looking one at each of those 3 sites. This was about a 64, 65-year-old shrub, and that was really easy to count. And this, you can see the rings in there, and that's maybe 5 or 6 years old, and those younger ones were a lot harder to count. Some of them are easier than others. Kind of depends on how smooth your cut is there. But then we took other measurements of those plants to try and correlate actual age to different plant size measurements so that we can come up with an equation for how to age these plants without chopping them down. What we found were really good correlations with everything that I measured pretty much, but the sample size was small. There was only 9 plants here that I cut down. So we measured the length and the width of the crown of the shrub, and then the height of the shrub, and then the stem diameter of the shrub, and correlated plant age, which we determined from counting the rings, to crown area, length times width, the crown cylinder volume, so an entire cylinder down to the ground and up to the height of the plant, and stem diameter, and then just plant height. And they all correlated really well, and stem diameter was the highest, and that was consistent with what I had seen in the literature, is that usually with bitterbrush, stem diameter alone is the best predictor of actual plant age. Also, so with these 9 plants, looked as well as possible for root nodulation, for the symbiotic bacteria Frankia, which I've talked about before, and found that nodulation that looks like this in the 3 oldest shrubs that I sampled, and did not see that in the younger shrub, the other 6 shrubs that I dug up, which is a little concerning to me because it doesn't necessarily take that long a period of time for this nodulation to occur. And so do we actually have nodulation in these older shrubs, but not in younger 15 or 20-year-old shrubs? I would find that hard to believe. And so what I haven't done with these nodules yet is try and extract DNA and get that sequence to confirm whether or not we actually have Frankia living in those nodules. If that's not Frankia, then either haven't excavated roots well enough to find the nodules, or we don't actually have this symbiosis here on the ranch, and that would make the work that we want to do with trying to establish this symbiotic relationship all that more important. Another piece of this work, it has been looking at seed viability from the 3 different sites. So I collected seeds, well, several people collected seeds from the 3 different elevation sites, and this fall I planted those at the 3 different sites along with some commercially purchased Bitterbrush seeds, and dug these holes out and buried these cylinders of mesh for rodent exclosures to keep rodents from eating the Bitterbrush seeds over the winter. So you dig a hole and put this cylinder down in it, fill it back in, plant your seeds, and then secure a mesh lid over the top of that. And here's a set of 3 replicate samples of the same type of seed planted at one site. So we have seeds from the upper, lower, and middle sites and the commercially purchased seeds planted at all 3 sites in triplicate like that. And in the spring we'll be able to go back and look at seed germination and hopefully get some idea of whether the different elevations or different plant cover types that these seeds came from might affect the overwinter germination of these seeds. So are these seeds preferentially or germinating better at one elevation and one plant cover type or another? The 3 different sites have pretty different plant cover types. The lower elevation site, it is a majority sagebrush and bitterbrush. The middle elevation site has a lot more spurge and cheatgrass, and the higher elevation site has a lot more knapweed than the other sites. For greenhouse studies with these seeds, we've been cold stratifying them in wet sand and then for 15 days, and then soaking them in a growth hormone, gibberellic acid, for 6 hours, and then they go on to filter papers like this in petri dishes to germinate. And a study that was done a while back said that after 30 days on germination paper, you could get up to 80% germination of these seeds. And so we're right now investigating this with seeds from the different sites, and then the commercially available seeds are in the cold strat right now. So our percent germination, we've only had the seeds from the different sites in germination trays for 12 days. Here's the study that I was referencing from 1960. This author's best or most efficient, I guess, combination of days of stratification and concentration of this gibberellic acid was 800 parts per million acid at 15 days of cold stratification. He got close to 85% germination of those seeds. And right now, with seeds from the upper, middle, and lower sites, after 12 days in germination trays, we're at about 20% germination. And so we're hoping that those that haven't germinated yet are going to in the next couple of weeks here. So the next steps here for this particular study are collecting soil samples from each site to send off for soil analysis to look at the physical and chemical composition of the soils and see if there are big differences there amongst the different elevation sites. We also want to be able to monitor browsing of bitterbrush shrubs next spring, well, through the winter, and monitor it in the spring. And so I'm looking into different ways of doing that right now. One potential way would be tagging a large number of shrub leaders that you actually measure now after the growth season is done, and then measure them again, the same leaders in the spring or early summer after spring browsing, and winter and spring browsing has occurred. to try and evaluate usage of these different areas and see if we have large differences in ungulate browsing in the lower, middle, or upper elevation study sites. And then we're also about to set up the greenhouse study to start looking at the inoculation potential of soil from each site. So the seeds that we're germinating will go into little pots, and we want to inoculate those pots with soil inocula from each of the different sites, from underneath bitterbrush plants that exist at the different sites. And if one site has the frankia that is able to infect the roots of these plants and give us that symbiosis, then we'll see nodule formation in the greenhouse, and those are, those nodules will be a lot easier to work with in terms of isolating those bacteria and potentially culturing those bacteria so that we can use those to inoculate other shrubs for restoration and reclamation work in the future. So.